Hello everyone and welcome to my last PowerPoint lesson for you guys this year. Um, this lesson is going to be about quadratic formulas. We'll start by looking back to what was that square thing again? What are squares? Well, let's take a look at this one. We have 2 squared, or 2 to the power of 2, whatever you would like to call it. What does this 2 mean? It doesn't mean that we multiply 2 by 2. That's a common mistake, but it doesn't mean that. In fact, it says 2 times 2 here, but that's because this 2 says how many times we multiply 2 with itself. So this 2 says we multiply it by itself twice. So we do 2 times 2. This equals 4. 3 to the power of 2, or 3 squared, means 3. How many times do you multiply it by itself? 2 times. So we get 3 times 3, and not 3 times 2. 3 times 3 equals 9, and that's the answer to this one. 5 to the power of 2, or 5 squared, not 5 times 2, but 5 times 5, equals 25. 2 to the power of 3, well, this 3 says we multiply this number, in this case it's 2, with itself 3 times. So we get 2 times 2 times 2. 2 times 2 equals 4, times 2 equals 8. Last one, I think, 10 to the power of 2, or 10 squared. 10 times 10 equals 100. That's really all you need to know for this lesson. Okay, quadratic formulas. The area of a square garden is calculated with the following formula. A is the area of the garden. A equals z times z. A equals z squared. Let's make a table. Okay. Well, let's just calculate some of this, right? We should just fill them in here. Z equals 0. Well, 0 to the power of 2, or 0 times 0 equals 0. 1 to the power of 2 equals 1 times 1 equals 1. 2 to the power of 2, 2 times 2 equals 4, etc. If we do it correctly, we get this table. Okay. This is simplified, but this is just how quadratic formulas work. It's just a formula where you have a power of 2 on a ladder. Okay. Here we go. Given the following formula, x to the power of 2 minus 2. Is this a quadratic formula? It is, since there is a power of 2. That's all that matters. Even if it would say y equals x to the power of 2 minus x, it's still a quadratic formula since there is a ladder with a power of 2 on it. That's all that counts. Fill in the table, well, we can do that. 0 times 0 minus 2 equals minus 2. There's not a lot much more to it. Fill in the next one, and this is where it gets interesting. Now we don't start with 0, but with minus 2. If we fill in minus 2 on the part of where we have x squared, well, what do we get? We put it into brackets, right? We learned that. Always put negative numbers into brackets when you square them. Minus 2 to the power of 2, and this only holds true if the minus 2 is in brackets, even on your calculator. It will be a wrong answer if you put it in there without brackets. This equals 4, since minus times minus equals a positive number. So minus 2 times minus 2 equals 4. Well, that number minus 2 equals 2. Same thing with minus 1. Minus 1 times minus 1. Put it in brackets equals 1. Well, 1 minus 2 equals minus 1. We do that for all the other numbers too, and we get this. Well, what do we see here? Minus 2, y equals 2. X is 2, y also equals 2. Same with the minus 1. Minus 1, 1, minus 1. There seems to be a certain symmetry between these two sides of the table. We'll dive into that a little bit later. We have the formula y equals 2x to the power of 2. Make a table from x equals minus 3 to x equals 3 and draw the graph. Well, we start with minus 3. We put it into brackets. 2 times 9 equals 18. Same thing with minus 2. Same thing with minus 1. Same thing with 0. Just pause it if it's going too quick and just try to understand the steps. Otherwise, you can scroll some pages back and listen to the explanation again. Well, since we know that this formula is symmetric, right, to this point, 18, 8, 2, 0. Well, what do we think happens if we put x equals 1 in here? It should be symmetric to the x equals minus 1, right? Exactly what happens. Why is that? Well, minus 1 squared equals 1. 1 squared also equals 1. So of course you get the same thing. That's the point of a quadratic formula. It's symmetric at some point. Well, 2 equals 8. And let me guess, 3 equals 18. And I'm right. This is the table. We see 18, 18, 8, 8, 2, 2, 0. Let's draw the graph to this one. And we see, indeed, it's exactly the same on the left side as it is on the right side, just mirrored. If we clap it over here, it should precisely fill in this line. That's what a quadratic formula does. We have a certain name for this graph. It's called a parabola. So, the graph of a quadratic formula is called a parabola. What's the lowest point? Well, we can see on the graph, it's right here. It's 0.0. We can also look at the table. We see the lowest point, so low, that means we have to look for the y coordinate, is 0. Well, that's when x equals 0. So the coordinate is 0.0. Question, does the point r, 2.6, lie on the following formula? How do we control this? Well, we know a coordinate consists of an x coordinate and a y coordinate. Well, we can just fill in the x coordinate and see whether the y coordinate holds true or not. So we have the x coordinate 2, we just fill it into the formula. We fill in the 2. So 2 to the power of 2 equals 4, plus 2 times 2 equals 4. 4 plus 4 equals 8. So we would get the coordinate 2.8. That isn't the same as our given coordinate. What does this say us? Well, we know for a fact that this one lies on the graph or on the formula, and this one doesn't, since the y coordinate when you fill in x equals 2 should be 8. Last question, then we're done for the day. Coordinate q 4.a lies on the graph, so we know for a fact it does lie on the graph. Calculate a. We know the x coordinate, it equals 4. We can just fill it in again. 4, filling in the place of x, 4 to the power of 2. Well, that's 4 times 4 equals 16, plus 2 times 4 equals 8. So 16 plus 8 should be 24, and I'm right. Well, that means we get the coordinate 4.24, so in the place of the a, we get a 24, which means the number for a is 24. That's all to this lesson. So what did we learn? A quadratic formula always has a variable with a square, for example, y equals x squared. Minus 2 in brackets to the power of 2 is correct. Minus 2 to the power of 2 is wrong. I will show you in a second why that is. Also holds true for your calculator. Yes, it will give you a different answer if you put it in brackets than when you don't put it in brackets. You can control whether a coordinate lies on the graph by filling in the x coordinate. That's all. So for all of you folks who want to see why this is true, you can stick around for one more second. It's really quick. And all others, I'll see you around. Well, the subtle difference here, if I can find my mouse, right. What this means is minus 2 in brackets to the power of 2, so minus 2, let's do this, times minus 2. Well, we know minus times minus equals plus, so minus 2 times minus 4 equals, minus 2 equals 4. When we do this, the squared is going to go first by rules of calculations. So minus, and the first thing we do is square the 2. So we get 2 times 2. Well, we know that you do the multiplication before the plus or minus. So we do 2 times 2 equals 4. We put the minus in front, giving us minus 4. This is the reason why you have to watch out whether you use brackets or not. I hope you enjoyed it, and yeah, bye.